Before I'm going on with my next weekend project, I thought I'd give you an update on the previous weekend project, which was building an LED temperature gauge. And actually, I've come to the point or the stage where I want to build in my temperature gauge, which you see here, into the bottom cap of my electric boiler. Now inside the cap you can see how the boiler is connected to the electrics in the house, and as you can see, there's in the top you can see the line and the neutral, which come into a thermostat, and the thermostat is really nothing more than an electromechanical switch which uses temperature to raise a certain I think a liquid or a gas, probably a neutral gas, inside a tube. And when the pressure of the gas rises to a certain level, it actions a switch, which then lets through the AC power to an electric resistance, which is what you see down there with the numbers 2 and 5. Now, as you can see, I have plenty of space in this bottom cap, and the plan is that I drill a couple of holes in the middle of it. In the middle, I mean centered vertically and horizontally. So that's what I'm going to do. I'm going to drill 2 tiny holes to house these LEDs, and I'm going to cover the whole circuit, back and front, with epoxy, so that it's electrically insulated. And once those 2 things are done, the holes and the epoxy, then we're going to mount the whole thing to the boiler itself. I drilled out 2 preparatory holes after measuring their position with the help of a caliper and a ruler, and it seems to be pretty well in the middle of the cap, which will be mounted eventually back on the base of my boiler. So on with widening them to the width of the LEDs, and then we'll mount the gauge inside the cap. And there it is, mounted inside the cap. So all I need to do now is connect it up to the boiler and attach the cap back to the underside of the boiler. The front is nothing that special. It's just 2 tiny LEDs sticking out in the front, and that's it. A blue and a red LED. Okay, so well, here we go. Let's mount it back onto the boiler. Before you're going to work on a device which uses raw AC power, like the boiler, which you see here, you should always check whether there is AC power actually running through it or not. So right now I'm tapping off the wires going to the heating resistor, yeah, to which I will attach my LED temperature gauge. Now, as you can see, the wires run all the way up to my voltmeter, and it reads out 0 volts. So that is safe. So the next thing to do is to actually attach or connect, I should say, the LED temperature gauge to the contacts, and then we'll have a go at testing it. So here we go. Next, you have to choose a spot where to attach the sensor, or in other words, the NTC resistor you see here. So I looked inside or to the underside of the boiler, and I decided that probably the very best spot would be this piece of metal you see here. This is attached to the sealing ring, to which the which runs inside a cylinder, which itself runs up into the water, which the resistance heats up. So this sealing ring actually gets the same temperature as the water once it is hot, since it is attached indirectly to the cylinder, which is poking, as it were, into the water which is above it. So I think this is the best spot to attach my sensor. So if you have your own boiler, then you should have a good look at where to place the sensor. Obviously, if possible, not too close to the resistor which heats the water, and as close as possible to the water without actually, of course, making physical contact with the water. Remember, I encapsulated this in epoxy. Never use a NTC resistor naked to attach to the metal of your water boiler, because if you do, you might electrocute yourself. So always encapsulate it in a non-conductive metal which is watertight, and epoxy is watertight. Okay? Obviously, if you're going to attach a sensor to something which gets warm or hot, you're not going to use anything plastic, okay? So that is why I use a stainless steel little wire to clamp the sensor against the metal, taking care, of course, that the wire doesn't make any contact with the metal here. Okay, so now let's close up the whole thing and have a go at testing it. And there you go, it's mounted. Now I should remind you that this is plastic, okay? So I made sure that in no way or shape my little device could make any sort of electrical contact with the metal part of my boiler. So if you're going to mount your device inside your boiler, fine, but then always check to make sure that it never makes contact with any electrically conductive part. So the best thing to do is to encapsulate it in polyester or epoxy before you mount it inside your boiler. Okay, so now let's have a final look how it looks when it works. And there you go. The boiler is on, and as you can see, the light is burning or glowing, and now it's a matter of waiting for the water to heat up. So I'm just as curious as you are, and as soon as the LED, the other LED for the hot water switches on, I'm going to make an update so as to show you that it does indeed work. And you can see for yourselves, I closed up the whole cover, so it's screwed back and front with Phillips head screws, and it's totally tight and secure against the underside of the boiler. So yeah, let's just wait and see. And here we are about an hour and a half later. As you can see, the water in the boiler is slowly heating up. Now both LEDs are lighted, which means that well, technically speaking, you could say we're halfway at having hot water. I mean, really hot water. So, yeah, it seems like the circuit works perfectly. So, well, I think this conclusively ends the project of having an LED temperature gauge. So, good luck to you all who build the same gauge, and well, have fun with it. As you can see, it does some useful work.